Bright Duty. Every student matters.
In the last lecture, we discussed about experimental or empirical probability, right? What was empirical probability of an event or experimental probability of an event? It was number of times, or you can say number of trials in which the event happened, divided by total number of trials. What do I mean by trials? I mean the number of times the experiment was performed, right? So once, if the experiment is performed once, it will be one trial, right? If the experiment is performed twice, then the number of trials will be 2. And number of trials in which the event happened means the event for which we are calculating the probability. Let us say you are calculating the probability of head on top when you are tossing a coin, right? Then we will say the event happened if there is head on top. So number of trials in which the event happened divided by total number of trials is the experimental probability. And we also discussed that probability of an event can be maximum 1 and minimum 0. Otherwise, it will be between 0 and 1. It cannot exceed 1, it will never be below 0, right? So let us do some of these questions in this exercise here. In a cricket match, a batswoman hits a boundary 6 times out of 30 balls she plays. Find the probability that she did not hit a boundary. So 6 times out of 30 she hits a boundary. So how many times she did not hit a boundary? Number of balls she did not hit a boundary is equal to total number of balls minus 6, because these are the balls on which this batswoman hit the boundary. So 30 minus 6, 24 balls were such on which she did not hit a boundary. So the probability she did not hit a boundary will be equal to number of times the event happened. In this case, what is the event? Not hitting a boundary. So 24 times out of 30 she did not hit a boundary. So 24 divided by total number of trials, or total number of balls in this case, is 30. So 24 by 30 is the probability, and 6 4s are 24, 6 5s are 30. So 4 by 5 is the probability, and if you want to write it in decimal form, you can write it as 0.8. This is the required probability, right? 1500 families with 2 children were selected randomly, and following data was recorded. Number of girls in a family 2, 1, 0, and number of girls 2 is 475 families, and 814 families have got 1 girl in their family, and 211 families are such who have got no girl in their family, right? Now compute the probability of a family chosen at random having 2 girls. Okay, let us look for the families who have 2 girls. 475 families have got 2 girls in their family, right? So probability that a family picked at random have 2 girls in their family is equal to number of times the event happened. Means out of these 1500 families, 475 are such who have got 2 girls. So 475 is the number that will come in the numerator, right? And divided by obviously 1500, that is total number of families that were being observed, or for which we are making these observations. So this will be the probability of 2 girls in a family out of these 1500 if you pick a family at random. So this will be, we can cancel it by 25. So 25 into 16 is 400. 25 into 19 will be 475, right? So 25 into 6 is 150. 25 into 60 will be 1500, right? So 19 by 60 is the probability of having 2 girls in a family if a family is picked at random. Now we can write it in decimal form also. This will be, when I divide 19 by 6, it will be 6 3s are 18, and then 6 1s are 6, 4, 3.16, right? Then you divide it by 10 because there is a 0 here. So 0.316 is the approximate answer for this probability that a family will have 2 girls chosen at random. A family will have 1 girl, the probability is 814 divided by the total number of families, that is 1500, right? So this will be equal to, now you can cancel it yourself and see what will be your answer. And now you need to take care of one thing. Compute the probability of family chosen at random having 2 girls, 1 girl and no girl. Now the families having 2 girls also come in this category, right? If you are asked what are the families who have got 1 girl, now the families having 2 girls may come in this category, right? Now in this question we need to calculate whether these families have exactly 1 girl. So the probability of having 1 girl is 814 by 1500. Now let us calculate it. This will be 407 and this will be 750. This is the probability of 1 girl in the family chosen at random. Third, the probability of 0 girls in the family chosen at random out of these 1500 families will be 211 divided by 1500. Okay, so these are the probabilities, required probabilities. Now let us add these probabilities. Probability of 2 girls out of these 1500 families, the families will have either 2 girls or 1 girl or 0 girls, right? So let us add these probabilities and check whether the sum is 1500 by 1500 or not. So the denominator is 1500, right? Let's check the numerator. 1 plus 4 is 5, 5 plus 5 is 10. So 2 plus 1 is 3, plus 7 is 10, 3 plus 8 is 11, plus 4 is 15. So 1500 by 1500, that is equal to 1. Sum of these probabilities is equal to 1. So this means out of these 1500 families, the families will either have 2 girls or 1 girl or no girl, right? There cannot be any other case, like a family cannot have 3 girls, right? So out of these 1500 families, so yes, the sum of their probabilities is equal to 1. In a particular section of class 9th, 40 students were asked about the months of their birth and following graph was prepared for the data so obtained. So now if you look at this bar graph, look at this month, in the month of January. How many students were born in the month of January? You will check it here. 3 students were born in the month of January. Now we need to find the probability that a student of the class was born in August. So how many students were born in August? We will check for the month of August here and look at this bar. So 6 students were born in August out of total 40 students that we are talking about, or that those were part of this observation or experiment. So, out of 40, 6 students were born in the month of August. So, the probability that a student of this class, of the class, was born in August is equal to 6 upon total 40, right. So, it will be 3 upon 20. 3 upon 2 is 1.5. So, 3 upon 20 is 0.15. So, this is the probability that a student is born in August. 3 coins are tossed simultaneously 200 times with the following frequencies of different outcomes. Okay. So, what are the outcomes? That we get 3 heads 23 times out of these 200 times the experiment was performed. We get 2 heads 72 times, 2 heads, or we can say this is 1 head, right. So, 1 head 77 times and 0 head 28 times. If 3 coins are simultaneously tossed again, compute the probability of 2 heads coming up. Now, depending on the, or based on the trend, or based on the data from the experiments that were performed 200 times, we will predict, or we will calculate the probability of 2 heads in the next toss. So, probability of 2 heads in the next toss will be equal to 72 divided by the total number of times the experiment was performed, 200. Okay. So, it will be equal to 18 by 59 by 25, right. Or if you want to convert it into decimal form, 18 by 50 or 72 by 200 can be written as 36 by 100, and you can write it in decimal form like 0.36. So, this is also correct, this is also correct, right. So, this is the probability of 2 heads coming up in the next toss. An organization selected 2,400 families at random and surveyed them to determine a relation between income level and number of vehicles in a family. The information gathered is listed in the table below. So, monthly income, the family is having monthly income less than 7,000, 1 vehicle per family was in 160 families. So, if I need to rephrase this, I will say there are 160 families who are earning less than 7,000 and have 1 vehicle. There are 2 families having income between 7,000 to 10,000 and they have above 2 vehicles, right. They may have 3 vehicles, they may have 4 vehicles, etc. So, suppose a family is chosen, find the probability that the family chosen is earning 10,000 to 13,000 per month and owning exactly 2 vehicles. So, we will look in this row because this row is for 10,000 to 13,000 income, right, and owning exactly 2 vehicles. So, these are vehicles per family. So, owning exactly 2 vehicles are 29 such families. So, there are 29 families with income between 10,000 to 13,000 and owning exactly 2 vehicles. So, find the probability. Let us say this is event 1. So, probability of event 1 will be equal to 29 by total number of families, that is 2400. Okay. You can leave it here, otherwise you can convert it into decimal form by dividing this 29 by 2400. I am leaving it like this. Let us say this is event 2, earning rupees 16,000 or more per month. So, this is the row that we are concerned about, owning exactly 1 vehicle. So, this is the column that we will look into. So, this is the number of times this event happened, or number of the families which earn 16,000 or more and have one vehicle exactly. So probability of event 2 will be equal to 579 divided by 2400, and this is your answer. Let it be event 3, earning less than 7,000 per month. So this is the row that we will be looking into, and does not own any vehicle. So does not own any vehicle means 0 vehicles, that is this column. So these are the families who earn less than 7,000 and own 0 number of vehicles. Okay, so PE3 will be equal to 10 divided by 2400. So you can write it as 1 by 240, and this is your probability that the families earn less than 7,000 per month and does not own any vehicle. Okay, this is the probability that a family chosen at random out of these 2,400 families have got income less than 7,000 and does not own any vehicle. Let us look for this event 4. So probability of event 4, earning 13,000 to 16,000 per month. 13,000 to 16,000 is this row, and owning more than 2 vehicles. So above 2 vehicles in this particular row, 25. Okay, so 25 is the numerator, and denominator we already know is 2400. Okay, so you can cancel it out, otherwise you can leave it like that also. Okay, probability of event 5, owning not more than 1 vehicle. So not more than 1 vehicle means either 0 or 1. Not more than 1 means either 0 or 1, right? So owning not more than 1 vehicle means this column and this column. The families that are in this column and the families that are in this column will be counted as the number of times the event happened. Okay, so we will have to add all these. 10 plus 1 11 plus 1 12 plus 2 14, 14 plus all these. So we will write it like this: 14 plus 160, 305, 535, 469, 579, and this will be divided by 2400. Okay, so 305 plus 35 340 plus 500 840 and 60 900 plus 100 1000. So this sum is 1000 plus what is this sum? 18, 8 plus 6 is 14, 6 plus 4 is 10, right? And then this 14 we need to add here. 1048 plus 14, and we need to divide this sum by 2400. Now look at this: 1000, 2000, and 48 plus 14 is 62. So 2062 divided by 2400 is the probability of owning not more than 1 vehicle, that is 0 or 1 vehicle. In a mathematics test of 100 marks, 0 to 20 marks were obtained by 7 students. 60 to 70 marks were obtained by 15 students, right? 15 students are there who have obtained marks between 60 to 70. Now when it is given in this class distribution form, these are classes, right? What is a class? That 0 to 20 marks is a particular class, 20 to 30 marks is another class. So when it is distributed in this class distribution form, this upper limit is not included in this class. What do I mean by it? That students who have obtained 30 marks are counted in this class and not in this one. Okay, so this is one set of information. Find the probability that a student obtained less than 20% marks in the mathematics test. So, when you say 20%, you mean 20 out of 100. So, the students who have obtained less than 20 marks in a test of 100 marks. So, this will be the area that we will look into. 7 students are such who have obtained less than 20 marks, because this 20 is that is the upper limit of this class, is not counted here. 20 is counted in this class. So, every student having marks between 0 to 20 has got marks less than 20. Okay. So, there are 7 such students. So, probability, let us say this is E1, probability of E1, that is student obtained less than 20% marks. There are 7 such students out of total 90 students. Okay. So, this is the probability that a student will obtain less than 20% marks. Find the probability that a student obtained 60 or above. So, probability, let us say this is event 2, probability of E2 is 60 and above. That means this class and this class. When I say class, I do not mean the class in their school, right? I mean class of marks. That 60 to 70 marks is a particular class, 70 to above marks is another class. So, 60 above means these students and these students. So, 15 plus 8, 23 students obtained more than 60 marks. So, 15 plus 8 by 90, that is 23 by 90 is the probability that a student obtained marks 60 or above, right. So, this was the question. Okay. To know the opinion of students about subject statistics, a survey of 200 students was conducted. The data is recorded in the following table. The student who like statistics are 135 in number, and 65 students are such who dislike the subject of statistics, right. Find the probability that a student chosen at random likes statistics. So, the first probability that a student likes statistics, student chosen at random likes statistics, is equal to 135 students liked statistics when the experiment or when the survey or observation was conducted. So, 135 out of total 200, that is 200 here. You can simplify it further. (27 by 40) is the probability that a student likes statistics if a student is chosen at random out of these 200 students. Second, probability that the student does not like it. Student does not like it is equal to, there were 65 such students who did not like the subject of statistics. So, if you choose a student at random out of these 200, the probability will be 65 upon 200. Okay. So, it will be 1, 3, 4, 0. So, 13 by 40, and if you check the sum of these, it will be equal to 1. Sum of these probabilities will be 1. Why? Because when you ask 200 students that you like statistics or not, and you give only 2 options, that either you like it or you don't like it, right. So, the student will either say that he likes it, he or she likes it, or she or he doesn't like it, right. So, every one of them will fall in these 2 categories only, right. So, the sum of these probabilities is equal to 1. What is the empirical probability that an engineer lives less than 7 km from her place of work, more than or equal to 7 km from her place of work, within half kilometer from her place of work. Now, distance in kilometers of 40 engineers from their residences to their places of work were found as follows. These are the distances of 40 engineers from their residences to their places of work. This is 5 kilometers. One of the engineers lives 18 kilometers away from his or her place of work. One of the engineers live 12 kilometers away from her place of work. Right? This is the way we will interpret this data. Now, less than 7 kilometers from her place of work. Less than 7 kilometers are these 5 kilometers, 3 kilometers, 2 kilometers, and you should start from this and then let's go row wise. Okay, so in this row, what are the entries that are less than 7? We are not talking about 7 here. We are looking for less than 7. So, less than 7 in this row is this one. In this row, it is this one, and this one. In this row, this 6 again. So, these are the entries or these are the distances which are less than 7. So, how many are these? 1, 2, 3, 4, 5, 6, 7, 8 and 9. So, 9 engineers live less than 7 kilometers from their place of work. Let us say this is E1. So, probability of E1 is equal to, how many did we count here? 9 divided by how many were under observation? 40. So, 9 by 40 is the probability that an engineer lives less than 7 kilometers from her place of work. Look at this second part. Let us say this is event 2, that an engineer lives more than or equal to 7 kilometers from her place of work. Now, this one is very simple to calculate because we have already calculated less than 7, right? These were 9 engineers. So, rest of the engineers live equal to or more than 7 kilometers. So, equal to or more than 7 kilometers, we can write it like this: engineers living equal to or more than 7 kilometers from their place of work is equal to, these 9 have to be subtracted from total 40. So, 40 minus 9, that is 31. 31 engineers live more than or equal to 7 kilometers from their place of work. So, probability of event 2 is equal to 31 by 40. Right. Look at the next part. Within half kilometers from her place of work. So, the third is within half kilometers. This is event 3. So, probability of event 3 within half kilometers. So, if I look in this data, the minimum entry that I find here is 2 kilometers, right? There is no engineer who lives lesser than 2 kilometers from their place of work. So, within half kilometers, 0 such entries are there. So, 0 by 40, that is equal to 0. The probability that an engineer lives within half kilometers from her place of work is 0. So, it is impossible event, right? There is no one who lives within half kilometer. Now, there is an activity suggested for you, that note the frequencies of 2-wheelers and 3-wheelers and 4-wheelers going past during a time interval. Let us say you take a time interval of 1 p.m. to 2 p.m. Okay. For 1 hour, you make this observation in front of your school gate, right? And you should be careful while you are observing these. You should stand at a safe position. Okay. Find the probability that any one vehicle out of the total vehicles you have observed is a two-wheeler. Okay. So, let us take a hypothetical case that you observe 100 vehicles. Out of these, some were two-wheelers, some of the vehicles were 3-wheelers, and some of the vehicles were 4-wheelers. When I say sum of the vehicles, let us take a hypothetical number for 2-wheelers as 20, 3-wheelers as 40 and 4-wheelers as 40. So, these are the 100 vehicles that you observed during that given time interval of, let us say, 1 p.m. to 2 p.m. in front of your school gate and standing in a safe position, okay, under guidance of your teachers. So, now we need to find the probability that any one vehicle out of the total vehicles you observed is a 2-wheeler. So, let us say your observations are these and you are asked the probability that the any vehicle picked at random from your observations is a 2-wheeler, will be equal to 20, because there were 20 times a 2-wheeler passed in that time interval. So, 20 by 100 and it will be equal to 1 upon 5 or 0.2. So, this is how you will find the probability, okay. And this experiment or this activity you should perform under the supervision of your teachers. Ask all the students in your class, this is another activity here, to write 3-digit number, okay, on the board. Choose any student from the room at random. What is the probability that the number written by her or him is divisible by 3? Remember that a number is divisible by 3 if the sum of the digits is divisible by 3. Yes, this is the test of divisibility by 3, that a number will be divisible by 3 if the sum of the digits in that number is divisible by 3. Let me give you an example. For example, 1, 2, 3. This number is divisible by 3 because 1 plus 2 plus 3 means 6 and 6 is divisible by 3. That means number 123 will be divisible by 3, and let me tell you what will be the quotient, 41. Okay. Now, let us say you ask all the students in your class. There are, for example, 30 students in your class, 30 students in your class, okay. And let us take a hypothetical case that 5 students wrote a number, 3-digit number on the board that was divisible by 3 and 25 students wrote a number that was not divisible by 3, right. So, 5 students wrote a number that was divisible by 3. Now, if you are asked what is the probability that you pick a student at random in your class and look at the number that she or he has written on the board, and the probability is that the number is divisible by 3. So, you will say probability of this event will be equal to, there were 5 students who wrote a number divisible by 3 and divided by total number of students, that is 30. So, 1 by 6 is the probability. Okay. Now, this is an activity. There may be more than 30 students in your class. Okay. So, you do it in your class under the supervision of your teacher, that every student write a number on the board, a 3-digit number, and then out of these numbers you calculate how many numbers are divisible by 3. And how will you do that? By adding the digits of the 3-digit numbers, right, like I did here, and see whether the sum is divisible by 3. So, you segregate those numbers. Let us say 40 students have written some numbers and 11 of them are divisible by 3. So, you write that 11 numbers are divisible by 3 and 29 numbers are not divisible by 3, and then you calculate the probability like I calculated here. Okay. So, this activity is to be done by you. 11 bags of wheat flour, each marked 5 kg, actually contained the following weights of flour in kg. So, it was marked 5 kg, but it actually contained somewhat lesser than 5 kg or somewhat more than 5 kg. So, these are the exact weights: 4.97 kg, 5.05 kg, 5.08, 5.03, 5, 5.06 and so on, right. Find the probability that any of these bags chosen at random contains more than 5 kg of flour. So, more than 5 kg. Number of bags containing more than 5 kg. Let us calculate. Let us count. 1, 2, 3. More than 5 kg means more than 5 kg and not equal to 5 kg. Okay. So, we will not count this. 1, 2, 3, 4, 5, 6, 7. There are 7 bags containing flour more than 5 kg. So, the probability, so there are 7 such bags, and probability that a bag chosen at random will contain more than 5 kg of flour will be equal to 7 divided by total number of bags, that is 11. So, 7 by 11 will be the probability. When it says more than 5 kg, you should not count this 5 kg here, right? Otherwise, you will arrive at a wrong answer. Okay. If it says contains more than or equal to 5 kg, if the question was more than or equal to 5 kg, then the answer would have been different. We would have calculated these and this bag also. We would have calculated, or we would have counted this bag and this bag also. Okay. Okay. Now, you are given a frequency distribution table regarding concentration of sulfur dioxide in the air in parts per million, that is ppm, of a certain city for 30 days. Using this table, find the probability of concentration of sulfur dioxide in the interval 0.12 to 0.16 on any of these days. And this is the data that was collected for 30 days of observations. A study was conducted. Now, this is the data that is given. A data obtained for 30 days is as follows. Okay, so this was the concentration 0.07, let us say, on a particular day, 0.01 on a particular day. When I talk about this interval here 0.12 to 0.16, I do not include the upper limit here, okay, but lower limit is included. So, if the data is 0.12, we will include that as our event that happened, but if it is 0.16, we will not include that observation as our event. Okay. So, let us say how many times the event happened, or how many times the concentration was in this interval, that is more than or equal to 0.12 and less than 0.16. Look at this carefully. I am not saying less than or equal to here. Okay, as I told you about the intervals in previous questions also. So, let us see 0.12 and more and less than 0.16. So, we will not count this, right? I have not counted these because these are not in this interval. 0.16 I will not count, okay, because this is the upper limit of this interval and it is not within this interval. Okay. Lower limit is to be counted in the interval. I hope I have explained it enough. This is also not the case. This is not the case. No, no, yes, this will be counted. Yes, this will be counted. This will not be counted. So, there are only 2 times the concentration was within the given interval, that is 0.12 to 0.16. Hence, the probability that the concentration of sulfur was between this interval, that is, let us say this is event 1. Okay. So, probability of event 1 is equal to 2 times the event happened divided by total number of observations, that is 30. So, 1 by 15 is the probability that concentration of sulfur dioxide was within this interval 0.12 to 0.16 on any of these days out of the 30 days. Okay. Okay. You were asked to prepare a frequency distribution table regarding the blood groups of 30 students of a class. Use this table to determine the probability that a student of this class selected at random has his blood group as AB. Now, out of these 30 students, one student has got A, another student has got blood group A. So, how many students have got blood group A? Now, this is not where our focus should be on. We are concerned about blood group AB. So how many students have got their blood group as AB out of these 30 students? So one student has got blood group AB, another student, one more student. So I have found 3 students out of these 30 students have got blood group AB. So probability that a student selected at random has blood group AB, student selected at random has blood group AB is equal to 3 students are there who have got blood group as AB. So 3 by 30, that is 1 by 10. This is the probability. Okay, you can write it in decimal form as 0.1. Right? So this is how you will answer this question. Okay, and you should consciously avoid this AB because there is a comma between them, right? This is blood group A, this is blood group B, this is blood group AB, right? Okay. So these were the questions in this exercise here. I hope the concept of experimental probability is clear to you, which is the probability of an event or experimental probability of an event is equal to number of trials in which the event happened divided by total number of trials, right? Thank you.